Hello, everybody. Can you guys hear me in the back of the room? Yes. Great, because I know I am a smaller person. I call myself a pocket ninja because I'm definitely shorter than the majority of people out there. I tend to give talks by talking, like walking around the room, but I'm behind a podium, so hopefully this will work with us. So I'm here from Amazon Web Services to talk to you about enhancing student outcomes, more than anything, trends that we are seeing in the university area. So I work with a team of solutions architects, as that was mentioned, who are working closely with universities and researchers around outcomes. So let's get into it. Okay, so our mission at AWS is to put machine learning in everybody's hands. But we understand this is a difficult problem, and that's been stated by many different speakers here today. We understand that it takes an ecosystem of technology working together to actually get to any type of outcomes in any way. So this is where you need everything from bringing in your data, storing it securely, then having different types of compute. And when I say different type of compute, I mean specialized micro-sized instances to large capacity instances or things like GPUs to analyze your data. And it's not just about having the compute power, it's about having the right machine learning frameworks, libraries set up on these compute instances in a way that can be scaled out. You need all of this together to get any project up and running. The types of trends into the industry. We're not here just to talk about AWS. We're actually talking about the results that we are seeing in the industry around education in three main areas: learning, research, and operations. The first place that we are starting here is around learning. This is, again, those student outcomes. These are things along the ideas of student retention, their success outside the university afterwards. What goes into student success? Let's start off with personalized learning. The idea that for every single student coming into the university area, there are places where they are excelling. How do we know what curriculum to offer those students who are already good in certain areas? And for places where they need to be double downing on because they're not doing as well, we need to identify those focus areas as well. Then, for all you professors who have content, or all that content in your university, how can we make it as accessible as possible? And when I say accessible, I mean to a more global audience, or even in terms of your local audience. How do you make your curriculum accessible to students who maybe English isn't their first language? There's also the idea of accessibility in terms of things like there's certain students who might do well with learning in an auditory way in lectures, but then there's those students who work better from reading, and this could be for multiple different reasons, from learning styles to other issues around hearing and vision. So let's think about the different, in terms of AWS, we have a variety of different products and services that are really helping accelerate, again, artificial intelligence and machine learning, driving things like learning for students. When it comes to the suite of products and services that we have, in terms of the learning side of things, we're seeing broad adoption around our artificial intelligence services. These are services that give you things like video and image recognition. So things along the lines of taking an image and being able to identify that you have a chair in that image. You have a house, a building with a level of confidence. When you have tools like this in your hands, think about the types of student projects that you can do very quickly, so you're not building those types of functionality from scratch. Instead, you have it in your hands so you can build additional products from that point on. We also have things like Poly and transcribe, the idea that you can go from text to speech or speech to text, and this is given to you out of the box so that you, again, you can build new functionality on top of these core services. And then we have services like translate and comprehend, the idea that you can have text in one language and translate it to another language very easily without going through humans to start off with. So let's take away some of that burden that's repeatable and make it so that you can build better products. And then comprehend the idea of finding those topics, those key phrases, those key words in documents so you can do that topical type of analysis. Now, those are services. Let's actually get into the meat of how these are solving problems. Echo 360. Echo 360 is really interesting in the student environment. The idea that you can go, take your professor's lectures, automatically transcribe it into text, and overlay graphics and diagrams that help out with the curriculum process and make this accessible to learners. Now, this can be useful in many different ways. Think about the learner who misses a class because they are sick. Think about students who are preparing for their exams and they want to go back and quickly find that section of a lecture that they need to help study again. Well, instead of just looking at the book, now they can go back to the lecture itself. And again, for those learners who like to learn visually, they like to learn off of reading as opposed to learning in an auditory way, well, this is a solution for them. And these are products that are built on top of AWS. Biodigital, another great example. The idea that you have the human body that is visualized in a 3D manner with descriptions of all parts of the anatomy, but that's interesting in itself. But the idea that Biodigital took their content and translated it into many different languages on AWS using our Translate service so that their content was accessible in Portuguese, in French, in Spanish. Now think about it, this is in one domain, Biodigital, in the human body, anatomy. But think about all the other curriculum that's coming out of your universities. How do you make it, again, interactable for people who are in different countries across the world in an easy fashion without needing translators, the people, instead you can get it there much faster? Or think about the students who are in your universities who English isn't necessarily their primary language. They can still make their content accessible to them. Then we have the idea of exams. At some point, students are going to have to take tests, right, to ensure that they are comprehending everything that's going on. Well, exams, traditionally, they are text, they are written, but now think about those students where vision's not a strong suit for them, or it's not something that they have at hand. The idea of taking exams and putting them into text, so you have into speech, so that you have speech interactive exams from this point forward for your students. That is important in terms of a lot of different university settings. Now let's go from the AI side of the world in terms of ways of getting curriculum out there to now curriculum tools, teaching tools for professors. We have a couple things that offered from AWS to help out there. We have AWS Deep Racer. This is taking a car, but in 1/18 the size of a regular car, putting it into the classrooms, putting it into students' hands so they can do things like thinking about the technologies of the future, like autonomous vehicles, modeling around a vehicle navigating certain terrains, both inside in a model or outside in the real world. Now students can have access to this for a fraction of the cost it would be if you're doing this with a full-size car. In addition, we have Deep Lens, the idea that taking video images in a device and then overlaying it with machine learning using SageMaker from the start, you can start processing images, processing videos, and then students can use this in their projects going forward. The next theme that we have here is around research. Well, it was already mentioned. Thank you so much for giving us a little bit of an intro into the concept that machine learning is hard. We heard earlier today that 80% of machine learning is in the prep. Yes, we are actually about to see that stat a little bit more here as well. But the idea is, like, in general, what we are seeing in the industry is it can take from 6 to 18 months to get from collecting your data, processing it, cleansing it, all the way into starting to train your models and then finally deploying it into production. Well, The hard part of this is really around cleaning and organizing your data, 80% of the work, as what was mentioned before. But really, what you were seeing in terms of the smaller parts of this pie diagram, this is really the meat of what your researchers want to be concentrating on. They want to be thinking about refining their algorithms, building training, deploying this out into production to actually have an impact. This is what they want to do, but all the other parts are hard. So this is where, in terms of on AWS, we have another suite of products and services that lets machine learning become more accessible and faster for your researchers. So this is everywhere from, on the lower end of things, having machine learning frameworks that are already integrated into our compute. And we understand that there's no one size, one pattern for machine learning, one set of libraries that work for everybody. Instead, you need to offer a variety here. So you have to be flexible. We need to be flexible so that your researchers can do the work that's specialized to them. So not only do we offer a suite of frameworks and infrastructure that your researchers can use, in addition to that, we have SageMaker, which integrates all of this together. The idea that you can do things from data classification and tagging automatically to integrating things together using your Jupyter notebooks. And this is all offered to you from a service. You no longer are spending time doing that massive prep work in terms of setting up your compute, setting up an environment before you can even get to the point of developing models and training your models. Instead, this is delivered to you faster. Where are we seeing this in the wild? In our research. So here's an example at Stanford University. They are processing over 80,000 photos of retinas. They're processing it using a bunch of different machine learning libraries hosted on EC2, expanding this out, and then looking at these images that are stored in S3. And more than anything, they've been able to find an early detection mechanism for diabetes by looking at images of the eye. So this is something where they can stand up this project, they can get it going, and then of course, since it's the cloud, they can shut it down whenever their research is done. But they were able to stand this up quickly because they were using the cloud. Another example, Clemson. This is a fun one. We're talking world records here. So with Clemson, they were analyzing thousands of documents and to do natural language processing, to do topic analysis. So when we talk about cloud, a lot of times we're competing with the supercomputers inside campuses that already exist. Well, Clemson was able to stand up over 1 million virtual CPUs all at once to do the processing of this document, to do this topic analysis. So this is the same level of compute that you have in supercomputers, and they were able to do this on the cloud. Again, breaking a world record. Digital globe. Every time you're talking about lots of data, this is satellite imagery of the Earth. They have over 100 petabytes worth of images that they were going through and analyzing using SageMaker to try to figure out ways of caching more efficiently and getting cache hits. So again, when you're talking about massive storage for any of your big data, machine learning type of problems, this is going on the cloud today. Next, San Francisco State. They were in the space of predicting functional sites in proteins and 3D molecules. But the interesting thing about this use case is actually about the fact that the people working on this project, they were not the machine learning PhDs. Instead, this was designed for the PhDs of chemistry, the PhDs of biology and physics, people who don't know machine learning inside and out. They still want to be able to do this modeling themselves. Well, they were able to come up with a framework on AWS that allowed them to do their work to do this, to find these predictional sites on these proteins, and without knowing machine learning inside and out. So these are the types of patterns that we're seeing in universities, where again, it's making machine learning more accessible to the other people within the university realm, those other researchers. The final trend area that we'll talk to today, And then I'm going to say ahead of time that I will use my time for questions. Instead, we will take questions on the side so that we can get you a little bit closer to your lunch today, because you guys might start to get hungry. We're running over a bit. So on the operation side of things, this is on the university campus as a whole, in the everyday lives of students. How can we get operationally better? And these are certain trends that we're also seeing in specific university campuses. College Board. This is even before a student necessarily becomes part of the university scene. This is the SAT takers of the world. Well, College Board went through and analyzed millions of calendars to figure out when should they have their next test date. Now, again, think of this in terms of your campuses. They were trying to figure out, like I said, the next test date, and what they analyzed was August. August was the right time frame, and this went against every intuition of College Board up until that point, because they figured August is a time when people go on vacations. I go on vacation, why would they host test dates then? But the fact of the matter is, this is what the data told them. The data gave them new insights, and from that, they hosted some test dates there, and lo and behold, all the seats for these test dates were taken up with a waiting list. And so in terms of new insights, that brought test taking and made it more accessible to students. Here's another example. And our last example for today. Alexa, Echo Dots. These maybe not traditionally thought of in the machine learning, artificial intelligence side of the world, but the idea is campuses are finding ways of bringing these into their students' lives, putting them into every dorm room so that students have new ways of interacting with their campus. So this is everything from, tell me what are the events going on today? What's my schedule? I want to register for my next set of classes next semester. These are different training techniques. These are different ways that we're bringing artificial intelligence and machine learning into our students' lives to affect their day-to-day. And these are things that are developed by students in a lot of cases as well. With that, I wanted to say thank you. You can find Jin Jun and I off on this table here on this side. He might raise his hand, or he'll just stand up. We are here to answer any of your questions going forward. Enjoy your day.